Welcome back. Today's lecture number 26. We're going to continue on electricity part 4. I just want to recall what we've done previously mathematically. We had these equations for our electric circuit. The Ohm's law, V equals IR, power, P equals IV. Once again, almost all of our problems can be done with these two equations, and then the two supplementary equations for power. Okay? Once again, all of the math problems are really easy. They're just plugins, and you just have to watch your units and convert. Okay? Keep practicing those conversions till they come second nature. What I'd like to do in this lecture is talk a bit about electric circuits and equivalent resistors. Excuse me. So let's first talk about your house and certain devices in your house. Imagine in your house you have your refrigerator. Okay, I still call it an ice box, but that's me. Okay, and then you also have your lamp. Okay, forget my artwork. Okay, so this is your fridge. There's your lamp, and then suppose you have your microwave. Remember that joke? How do short people say goodbye with a microwave? All right, back to the lecture. And suppose these things are all connected to all devices, okay? There's your TV, your 9,000-inch TV, or whatever you have in your house. Okay, each one of these devices in your house has a resistance. So if I'm going to draw an electric circuit, I'm not going to draw a refrigerator, and I'm not going to draw a lamp, and I'm not going to draw a microwave. I'm not going to draw some TV, obviously, because I can't draw. What we do instead is we represent each of these devices by the fact that they have a resistor. Now, one device that we love having resistance, remember, resistance means you're losing energy, entropy, energy lost to the universe, and all that. One device we want to get hot and give off a lot of energy is a toaster. We put electricity in a toaster, and we have devices that have a very high resistance, so the pieces of metal get very hot, and they toast your bread. Inside of a toaster, those little pieces of metal look something like this squiggly line. This is going to be our symbol for a resistor. So if I have a refrigerator, I call that R1. If I have a lamp, I'll call that R2. If I have a microwave, R3. If I have a TV, R4. Notice I changed the path. Does it matter? No. I'm just going to keep these for now and close this. Okay? Remember, I need some type of V. I'm going to put a V here. What is V? V is the potential difference that'll make current flow. So I is going through this entire circuit. And I want you to look very carefully at the circuit I drew. Suppose a current comes from, I don't care if it's a battery or your power source, I don't care what it is. If the current comes here, it goes through R1. Then goes through R2. There's nowhere else to go. It continues through R3. Again, nowhere else to go. Doesn't matter, it changes direction. The only place for it to go is through R4. In something like this, all of the devices, the refrigerator, the microwave, or R1, R2, R3, R4, all of the devices have the same current. If all of the devices, all right, forget devices, we'll say resistors, have the same current I, okay? We say that the resistors are connected in series. I'm going to make sure you see this word, series. So a series connection of resistors means they all have the same current. So R1, R2, R3, R4 are all connected in series. Okay? I'm going to erase this for now and redraw it. and give you a make-believe problem. Suppose we have a circuit like this. Okay, I'm not going to draw a potential difference V. We're going to assume there's something making the current flow. Okay, so let's say this is 10 ohms, 20 ohms, 30 ohms, 40 ohms, and here 20 ohms. Okay, so I have 1, 2, 3, 4, 5 resistors. Are they in series? Well, let's look. If a current goes through here, it continues through there, continues, right? So these resistors are all in series. I'll call this R1, R2. It doesn't matter what I call them, R3, R4, and R5. What we want to do is replace these 5 resistors in series with a single equivalent resistor. Replace the 5 resistors in series with a single resistor, with a single, and we call this equivalent resistance. Equivalent resistor. So we want this circuit to be replaced by this and call this R equivalent. So we need a rule for series circuits. Okay? Well, a rule for finding the equivalent resistance for series circuits is very easy. R equivalent series is just equal to R1 plus R2 plus R3 plus ... You just simply add up the resistors. Okay? So for the case I just gave, R equivalent, EQ, is equal to 10 plus 20 is 30, plus 30 is 60, plus 40 is 100, plus 20 is 120. So R equivalent would be 120 ohms. So that would replace by this, a 120 ohm resistor. Those 5 resistors in series are the same as having one resistor equal to 120 ohms. Okay, so that is equivalent to that. So resistors in series, how do we know they're in series? If they're in series, they all have the same blank. Test question. Resistors in series all have the same current, I. Okay? Fantastic. Let's keep going. Well, don't they always have the same current? No, 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 no. Let's watch. So imagine you're at the mall with your friends, if we could be at a mall, okay? And here you are at the mall. You come to a point, and there's 3 places to go. So suppose this is the current I. This is you and your friends, and you decide to go to 3 different stores, okay? So I could call this I1, I2, and I3. So you split up. It's clear that if you have 10 people, that when you split up, I1 plus I2 plus I3 should equal 10, or the original amount. So this is called conservation of electric current, or electric charge, electric current, which just means electric charge. So what we're saying is the current into a point or into a junction that goes in must be equal to the current that comes out. The current in equals the current out. That's the conservation law. What you start with is equal to what you finish with. Now, suppose here I put R1. Suppose here I put R2. Suppose here I put R3. Now, if this is a mall, then I can imagine R1, R2, and R3 are stores, and they slow you down because they're stores. Clearly, the number of people going through this store is not the same as the number of people going through that store, is not the number of people going through. They could be the same, but in general, they can be different. So, since the current through each resistor is different in general, we say that these resistors are not in series, but they are in parallel. Resistors in parallel, called a parallel circuit, do not have the same current, but do have the same electric potential difference V. Okay, so resistors in series all have the same current, but they have a different potential difference. Resistors in parallel have the same potential difference, but a different current. Okay, resistors in series are like Christmas lights or Hanukkah lights, right? If one goes out, the current stops, all the lights go out. Okay, now see, the current I breaks up into I1, I2, and I3, goes through each respective resistor, and then meets up here, and then again goes back to I, right? I1 plus I2 plus I3, I1 plus I2 plus I3 has to equal I. Same conservation law. Our goal is to replace these resistors in parallel with a single equivalent resistor. Just as we did for the resistors in series, except now we need a different rule for resistors in parallel. So let's look. Let's write the mathematical relation for resistors in parallel. I will do a very simple example, and then I'll do a slightly more difficult problem. So here's the equivalent resistance parallel. Okay, so here's what it says. 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus, you add them up. That's 1 over R. So let me show you a very simple example. All right, so watch this. Suppose I have okay, here's my junction. So here we have R1, R2, and let's do R3. So these are my three resistors. Let's just say that this is equal to 3 ohms. And let's say that's 3 ohms. And let's say that's 3 ohms. So the question is, what is R equivalent? What these three resistors in parallel are equal to what equivalent resistor that we have to calculate? So our rule says 1 over R equivalent is equal to 1 over 3 plus 1 over 3 plus 1 over 3 is what? It's just 1, or 1 over 1. R equivalent then is just equal to 1 ohm. So these 3 ohm resistors in parallel are equivalent to a single resistor, equivalent resistor, equal to 1 ohm. Same problem, except for now I'm going to change this. Suppose I put this as 2 ohms each, and I can change them, but you'll see, we'll do that next. 2 ohms, 2 ohms, 2 ohms. What is R equivalent? Well, R equivalent now is 1 over 2 plus 1 over 2 plus 1 over 2. A half plus a half plus a half is 3 halves. Now, on an exam, choice A for what is R equivalent would be 3 halves. Is 3 halves the answer? The answer is no. That's not the answer. 1 over R equivalent is equal to 3 over 2. So to get what R equivalent is, you need to flip the whole equation. So R equivalent over 1, which is just R equivalent, is equal to 2 over 3. 2 over 3 ohms. 2/3 is what? 0.67 ohms. So that's the answer. The answer is 2/3 of an ohm, or 0.67 ohms, not 3 halves. You must remember to flip it. One more quick example, okay? Suppose, I hope you all got that. Suppose that's 2 ohms. Suppose this is 3 ohms. Suppose this is 4 ohms. What is R equivalent? So I have 2 ohms and 3 ohms and 4 ohms together in parallel. What is R equivalent? Well, ask your children. Go back to 4th grade. We need to do fractions. 1 over R equivalent is equal to 1 over R1, 1/2, plus 1 over R2, 1/3, plus 1 over R3. Okay? How do we add fractions? Well, is it a half plus a third plus a fourth is 2 plus 3 is 5 plus this is 4. 5 plus 4. Is this equal to 1/9? No, no, no. How do you add fractions? You find the common denominator. Remember that? Find the common denominator. What's the common denominator between 2, 3, and 4? I think it's 12. Okay? So 1/2, hopefully you know how to do this, is 6 over 12. 1/3 is 4 over 12. And 1/4 should be 3 over 12. Now we have a common denominator, so we have 6 plus 4 is 10 plus 3. So this is equal to 13/12. That is equal to 1 over R equivalent. So once again, is R equivalent equal to 13/12? And the answer is no, no, you must flip it. So R equivalent over 1, if you want to just flip it, is equal to 12 over 13 ohms. That's the answer. Not 13 over 12, 12 over 13. You need to flip it. Okay? So resistors in series, what do? You just add them. Resistors in parallel, you add the inverse. Okay? So let me give you a cute problem, shall we? It's going to look really, really hard, but it's going to be really, really easy. Yeah, sure. No, it'll be easy, I promise you. Okay? I want you to watch. Let's make something up. 10 ohms. 10 ohms. 10 ohms. 30 ohms. Bear with me. Okay? 60 ohms. 60 ohms. 60 ohms. Okay? Do. 30 ohms. 30 ohms. 80 ohms. I'm going to put 4 resistors here. Okay? Isn't that a great sound? I'll make this 40 ohms. I'll make this 40 ohms. I'll make this 40 ohms. And I'll make this 40 ohms. And what we want to do is replace this entire circuit with one equivalent resistor. Okay? Here's where you need to pause the video, go have a glass of wine, maybe a shot of vodka or some water. Take a look at this problem and say, this is impossible. There's no way I can do it. I'm going to show you how to do it. No calculator, very simple, just using our rules. Remember, we have 2 rules. Resistors in series, you just add them. Resistors in parallel, you add the inverse. So we're going to do the parallel ones first, and then we'll see that everything is in series. So I want you to look. There's 10 ohms. Let's look at this. Do I have a colored pen? Let's see. Let's see if this works. Ah, a nice pink pen. Everybody look. Okay, pay attention. R equivalent here is 1 over R equivalent is what? 1/10 plus 1/10 is 2/10. Now we have to flip it. You have 1/10 plus 1/10 is 2/10. When you flip it, 10 over 2 is 5 ohms. So this is 5 ohms. Can everyone see the pink? 5 ohms. This is okay. It's 30 ohms. Let's get R equivalent for these 3 60 ohm resistors in parallel. 1 over R equivalent for these 3 resistors is 1/60th plus 1/60th plus 1/60th is 3 over 60. When you flip it, you get 60 divided by 3. 60 divided by 3 is 20. So this is 20 ohms. You getting the game? You catching on? All right, you do this now. Do it quick. 1 over R equivalent is what? 1/30th plus 1/30th is 2 over 30. Flip it. 30 divided by 2 is 15. So this is 15 ohms. Good? This is okay, 80 ohms. We have 4 resistors here. Same game. Let's do the equivalent for resistors in parallel. 1/40th plus 1/40th plus 1/40th plus 1/40th is what? 4 divided by 40. Flip it. Remember, they're in parallel. 40 divided by 4 is 10. So this is equivalent to 10 ohms. So now we have 10 ohms, 5 ohms, 30 ohms, 20 ohms, 15 ohms, 80 ohms, and 10 ohms. They're all in series. So what's our rule for series? Our rule is just add them. 10 plus 5 is 15, plus 30 is 45, plus 20, 65, plus 15, 75, 80, plus 80 is 160, plus 10, 170. So this whole thing is equal to one resistor of 170 ohms, if I didn't make a mistake. Okay? So that whole circuit is equal to one resistor equal to 170 ohms. So R equivalent is 170. Do you need a calculator? No, I make it so easy. You just need to know fractions and calculate in your head. All right, I'm going to erase, and let's see if we can fit another one in this video. Okay? And I won't wash the board, so I apologize that it looks a little dirty. But we're going to do another one of these problems, okay? Oops, that's my pink one. Sorry. Okay, here we go. 8 ohms. 16 ohms. 16 ohms. 24 ohms. 24 ohms. 24 ohms. 20 ohms. One, two, three, four. Okay, there's four resistors, and I'll make this 40. I'll make this 60 ohms. 80 ohms. Let's do 80 ohms. 80 ohms. 80 ohms and 80 ohms. Okay, and one more we'll do here. Oops. 48 ohms, 48 ohms, and 48 ohms. So we want to find R equivalent to this circuit. So let's play the same game. First, let's put everything, we want everything to be in series. So let's calculate each of the individual resistors in parallel. Okay, remember our rule, 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus whatever. All right, so let's go. 1/16 plus 1/16 is 2/16. Flip it over. 16 divided by 2, this is 8 ohms. Fantastic. Parallel, 1/24 plus 1/24 plus 1/24 is 3/24. Flip it. What do you get? 24 divided by 3, 8 ohms. There's 20 ohms. Let's look at this one. 1 over 80 plus 1 over 80 plus 1 over 80 plus 1 over 80 is 4 divided by 80. Flip it. 80 divided by 4 is 20 ohms. And finally, 1/48 plus 1/48 plus 1/48 is 3/48. Flip it. 48 divided by 3, 16 ohms. So the equivalent resistance is 8 plus 8 plus 8 is 24, plus 20 is 44, plus 20 is 64, plus 16 is what? 74, 80. So the equivalent to this whole thing is 80 ohms. That's R equivalent. And that's my answer. All right, go practice, and I'll see you next time. Okay, not too bad, right? Not too bad. Take care.